All right, we're back. We're on page 126, talking vectors. And there's a couple of things at the top of this page. There's a couple of things you pretty much already know. So this is a big idea. We use it all the time. So every vector can be written as its magnitude times a unit vector in the direction of the vector. How do you know the direction of the vector? You know its direction angle. How do you know the direction angle? Probably a unit circle point or inverse tangent and think about the quadrants, or you convert to polar on your calculator, like a lot of ways. But if you know the direction angle and you know the magnitude, you can write a vector as magnitude times cosine theta, sine theta. Cosine theta, sine theta is just unit circle. These are all things we know. So we actually know two different ways of writing unit vectors. So one is vector divided by its magnitude. The other is cosine theta, sine theta, where theta is the direction angle. So it's a big deal. And now let's introduce a new idea. So there's actually another notation for vectors, and it's called like unit vector notation. And the unit vector notation is, what if we looked at the plane as really just being always scalar multiples of a unit vector in the x direction and adding to that some scalar multiple of a unit vector in the y direction. So what we're talking about there is we're saying that we have an I vector, which is just 1, 0, and we have a j vector, which is 0, 1. So these, in some ways, these vectors determine the x and y axes. As you do more math, you'll see like maybe even more so than you're currently thinking. So we can write any vector as a scalar multiple of these. So for example, if I had 2, 3, I could say that that's actually 2, 0 plus 0, 3, which is actually 2 times 1, 0 plus 3 times 0, 1, which is, according to what we just said, 2i, not the imaginary I. So you don't want it to be italicized or cursive or whatever, just like a straight up normal printed I, and 3j. So that's a lot of work. I mean, anybody would just look at 2, 3 and be like, oh, it's 2i plus 3j. So we can write every vector as a linear combination, which means like something times the first one plus something else times the second. Every vector in 2 dimensions can be written as a linear combination of the vectors I and j. They are called the standard unit basis vectors. Standard unit basis vectors. Did I write that anywhere? Probably not. Oh, I did. Standard unit basis. Thank God. I did not want to have to write that. That was a long one. Standard unit basis vectors. So you can use them to determine every other vector in the plane, and that's kind of neat. So let's see, let's use them. So write each of these using unit vector notation, so ij notation. The direction vector of the line, -5/3 x plus 2. So I look at delta y over delta x is, I'm going to say -5/3. So delta x is 3, delta y is -5. So in component form, I might say that my vector is 3, -5, but I'm supposed to say it's 3i minus 5j. So this is one of those things where it's like, I don't know, you got to know things, right? Like you don't want to be thrown for a loop when you're walking around and somebody's like, oh, -9i plus 8j. And you're like, what? I thought we were talking about vectors, and vectors look like ordered pairs. Well, sometimes, other times, they look like this. They look like weird linear combinations of I and j, right? Because I is the x-axis, basically. It's 1, 0. J is the y-axis, which is 0, 1. And then if I add -9 times 1, 0 plus 8 times 0, 1, I will get -9, 8, which is the vector. It's just another way of writing it. So here, the vector AB. So start at A, end at B. So AB. So I'll be honest, I do everything in component form, and then if it tells me I need to use ij, then I'll do it. But otherwise, I definitely don't. -4 minus 3 is -7. 7 minus -8 is 15. So I'm going to say it's -7i plus 15j. And like, I don't know, I never do you could, I guess, mess around with these on your calculator. Like you could define I and j, and then like do -7i plus 15j and see what you get. I don't know. I don't know why you would do that. So let's see, CD. So -4 minus 12, 7 minus -1. So this is going to be -16i plus 8j. These are like practice, I guess. What on earth? Okay, so first thing you can do for sure, because why not, is just say that this is going to be the sine of 5 pi over 12. Geez, 5 pi over 12i. Could use a half angle formula on that. Plus the sine of 5 pi over 6j. That's gross. So this, like if you were going to, you would say that you're doing the sine of 5 pi over 6 over 2 is the square root of 1 minus the cosine of 5 pi over 6 all over 2 is the square root of 1. The cosine of 5, oh great, cosine of 5 pi over 6 is negative radical 3 over 2, so you plus radical 3 over 2 over 2, which gives us quickish math, I guess. We would end up with 2 plus root 3 over 2i. And then the sine of 5 pi over 6 is 1/2 plus 1/2 j. Gross. So what's the direction angle of this? The direction angle, so I can think of two ways to get it. Like since I did all this work, it's going to be the arctan of this over this. Or I could just say that the direction angle, so I'm going to say like theta sub v, is the inverse tangent of the sine of 5 pi over 6 over the sine of 5 pi over 12. Because like, I mean, I'm not going to know it anyway. So I would go with that. Let's look at that one. Let's look at that one on the calculator just to see, right? So I threw a 14 formula thing in there. I did a half angle on that, which is kind of weird to begin with. So if what could we do? We can do, okay, sine of 5 pi over 12, comma, sine of 5 pi over 6. Man, that cursor is just 100% of the time in the way. So we get this, which is like really annoying because it's like a simplified version, I guess, of what I had. Get a decimal. Let's just check. Square root. Oh, what am I doing? Like I'm saving this document. Square root of 2 plus square root of 3 over 2 is 0.9. So we got that right. So that's good. And then, so I can think of two ways to get the angle. So I can do arctan of sine of 5 pi over 6, sine of 5 pi over 12. So what's the exact value of that? Okay. Or this, the approximate value. Or we could have done, let's convert that to polar. Convert to polar is like a superpower once you know what you're doing. Menu 7C, convert to polar. So it's going to give me the magnitude and the direction angle. So the exact direction angle looks like what we got. The magnitude is nuts. 0.477, yeah. So either way, I'm content with the exact value that we wrote because can't do better by hand. So what's the point? So let's go back and look at this. Maybe you could do it. Just kind of not letting me go back to the notes here. Let me all right, hold on. Let me try one more time. I don't know what you're currently seeing. I hope it's not a giant version of my head, which it very well might be. I'm gonna try this one more time. Share, and then I gotta do this. I gotta do this. Oh, it might work. It did. Yay! All right. So these are all the answers. Using I and J, it's not a big deal. I mean, if a question asks you to use I and J, put your final answer in terms of I and J. Do all your intermediate work however you want to do it. Nobody's gonna judge you for that. But anyway, I'm gonna end this here. I will be back in the next one to do some more, and I will see you there.